Assalamu alaikum rahmatullahi barakatuhu. Subject Computer Science, Class 11th Standard Year Section, Chapter number 6 Algorithmic Problem Solving Techniques, Part 1. In this lesson, we are going to discuss the following topics: algorithms, algorithmic problems, building blocks of algorithms. The overall syllabus focus on programming techniques of computer science syllabus. Computer application syllabus focus on how to use computer software, but computer science syllabus focus on how to develop a software. So developing software means programming. For programming, the programmer should have some basic knowledge about the programming. Then only he able to give the uh, give its best to the programming and develop a best software. So one of the basic knowledge or concept for programming is algorithm. So this is what we are going to discuss in this chapter. What is algorithm? Algorithm is a sequence of instruction to accomplish a task or solve a problem. So in other words, we can say algorithm is a step-by-step procedure to solve a problem. We use softwares, we develop softwares using programming to solve any problem. For example, if you want to hear a sound or see a video, then we should need a software which can able to play sound and video. That software is known as players. So player is a software which contains many programs. That each and every programs contains thousands of instructions, and the instructions are formed in a manner to solve our problem hearing sound, viewing videos. In same way, the another software called Tally, of course, it is a accounting software which is used by the accountants for maintaining accounts of companies. So the focus of this software is to solve the problems of accountant. So to solve any problem, we develop software. To solve any problem, we give instructions. That instructions are the solutions for the software. So before we create a program, we should know what is algorithm. So before we give any instruction to computer, we should know how to give the instruction. That is called algorithm. So algorithm is the procedure where we learn how to give instruction, how to form instruction, how to program, how to form a program. So to form an algorithm, the main goal is to solve a problem. The important points of the algorithm is to satisfy the user. Somehow it is just like a recipe which resulting in process of cooking. So algorithm can be compared to recipe and resulting process to cooking. We are interested in executing our algorithm in a computer. A computer only execute instruction in a programming language. So for algorithm, there is no need of any language, but algorithm is the ideas. Algorithm is the methods. Algorithms are the techniques by which we are going to use any programming language and try to convert our techniques, our procedure into programming language and try to develop programs. Through the programs, we solve the problems. So before we get into the programs, we should know what is algorithm. So algorithm is the step-by-step procedure to solve any problem. Therefore, ultimately, algorithm must be expressed using statements of programming languages. When we create any algorithm, by using that algorithm we can create programs by using any type of programming languages like C, C++, Java, scripting, Python. In our syllabus we are going to see how to use programming C++. So before that we should understand the programming techniques called algorithm, specification, composition and decomposition, which we are going to discuss in these chapters. So first we see what is the algorithm. So of course we know algorithm is the sequence of statements intended to solve a problem. So whenever we use to solve any problem, we should know how to start the program, how to start the how to start our solution, how to end our solution, and each and every steps there we should need some inputs. By using that input, we can process the input and create a new output. For that, we need to know what is the relationship between input and output. So this is the important point we discuss in this chapter. First, we should know what is algorithm. Again, next, what are the inputs required for that algorithm. So how we are going to execute the algorithm, how we are getting the output, what is the relation between inputs and outputs. So next topic is example for algorithm. For example, if you want to add two numbers, for example 2586 plus 9237. So this is the problem called some computation. So for that problem, how we can create algorithm? So to add two numbers, we proceed by adding the rightmost digit of the two numbers. So this is the first step of algorithm. Then the next rightmost together with carry that resulted from the previous right position. And so on, the computation process for adding 2586 and 9237 is illustrated. So here you can see what is algorithm. If you want to add two numbers, we should start from the right side and add the numbers. After adding two numbers, we go for the next number, next rightmost number, and if there are any carry numbers, then we use that carry and add all the numbers. In the same way, we go for the left side of each and every number, digits of number, and we solve that problem. So this is a simple example for algorithm. Now we are going to see some of the real life algorithm problems. So in example, we can see, consider the well-known goat grass wolf problem. So first understand this problem. So very simple problem, but we want to create an algorithm for that problem. So now I'm going to use MS Paint software to explain this problem. For create problem explained in this, that is goat grass wolf. Consider there was a river. Consider there was a river. Each and every river, we know there was two sides. In one side there was a goat, in another side and the same side there was a farmer and a grass. So what is the problem here is the goat, grass and wolf should cross the river and reach the next side of this river without any damage. So in the right side, consider in the right side, there was a goat, there was a farmer, there was a wolf. All three members should carry this river, should go through this river and reach this side of this river without any damage. This is the problem. How they travel? So here you can see your farmer wished to take a goat, a grass bundle and a wolf across a river. However, his boat can only one of them at a time. So in one time, only two members can travel in a boat. So several tips are necessary to cross the river. Moreover, the goat should not be left alone with grass, otherwise goat would eat the grass. And wolf should not be left alone with the goat, otherwise the wolf will eat the goat. So this is the problem arise when these three members want to cross the river. How can the farmer achieve the task? So this is the question. So this is the problem. For this problem, you should write the algorithm. So in the same way, there was another problem. Consider the chameleons of Cromuland. So here, what is the problem? You should imagine there was an island, namely Cromeland. There are three different types of chameleons. They are red, green, and blue chameleons. So here, what is the problem? Whenever two chameleons of different colors meet, they both change color to the third color. So again I repeat, whenever two chameleons of different colors meet, they both change color to the third color. So consider red. If red and green chameleons meet to each other, then their colors is converted into blue. So for which of number of red and green blue chameleons it is possible to arrange a series of meeting that result in all the chameleons display the same color. Here we want to create a procedure or algorithm and create a series of meeting of different chameleons to convert them all into a same color. So this is the problem. So we want to convert all the chameleons into a single color. It may be red, it may be green, it may be blue. It is up to our choice. But somehow we want to convert all the chameleons into same color. So this is the problem. So this is the different types of real life problems which are given here for your understanding. So try to solve this problem. Of course, many of the students know about these problems already. They already discussed in previous classes. Now we are going for next topic called building blocks of algorithms. So whenever we try to create any algorithm, the important things for creating the algorithms are building blocks, which are going to discuss here. There are four building blocks are here. Number one, data. Number two, variables. Number three, control flow. Number four, function. Without these blocks, we are unable to form an algorithm. So we should know what is data, what is variable, what is control flow and functions. Then only we can able to create the algorithm. After creating the algorithm, we can create programs using any language. Through this programming language, we can solve the problem. So the basic thing is understand algorithm. To understand the algorithm, we should know these details about these four blocks. So first block is data. What is data? Algorithm takes input, process the data and produce output. So data, which we already discussed in the first chapter, that data are the raw fact about any man, place, things. So the purpose of programming is convert the data into information. So we accept data, we process data and we convert the data into information. So information is also a data, but the information is a processed data. Data is a raw fact of it about any man, place and things. So I hope you understand what is data. For example, there are instructions for doing arithmetic operation on numbers. For example, if you want to do adding, subtracting, multiplication, division, then anyone then if you ask to add any two numbers, then you ask the numbers. Without number you cannot execute the addition process. Without numbers you cannot execute the subtraction process. You know how to add, you know how to subtract, but without number how you can add? So this is the called datas. The numbers are the datas. So when we proceed the numbers into the instruction, then that process is called processing data. After when we convert that number into a new number, for example if you are using 4 plus 2, then 4 and 2 are the datas, plus is the operation, that is addition operation, that is some process is going on the data, then these 4 plus 2 datas are converted into a new data called information. Here the result is 6, so 6 is the information. So 6 is also a data, but this is output data. Then we can call this output data as a information. 4 and 2 are the input data because they are raw data given as a input to the process for any algorithm. The next block is variables. So in computer, if you want to accept data, if you want to process the data, and if you want to produce information, then we should use the memory. for storing the data. Of course, there are many memory spaces available in computer, but how we can store any data in memory, then how we can retrieve the data if you require. So this is the question raised whenever we try to store any data in computer. Then the solution is variable. So variable is the name boxes for storing data. For in memory location, each and every memory location can be reserved, and the reserved memory location can be allotted with a name. That name is used for processing. It may be used for calling the values. It may be used to storing the data into the memory location. So these names are called variables. In definition, you can see variables are named boxes for storing data. Here boxes refers to memory. So when we do operation on data, we need to store the results in variable. The data stored in a variable is known as the value. So each and every box is the memory. For each and every boxes we allot a name. That name is variable, and value which we store inside that box is called value. So here you can see the data which was stored inside that box is called value. We use three terms here. Number one, memory box. Number two, variable. Number three, value. So memory box, of course, it is a hardware block where we store the data. Number two, the value, which was the data which used to store inside the box. Number three, name of that box is called variable. So using that name only, we can access the data inside the memory box. We can access the memory itself. So this is called variable. So the second concept, we should know what is variable. So as a process evolves, the state change. How do we represent the state of the process? Here there was another example called state. A state at any point of execution is simply the value of the variable at that point. So when the process starts in a single memory location, the value may be changed depending upon the instruction. So each and every time, whenever the value change inside that memory location in the variable, that state, that value, changed value is known as state. For example, take a traffic signal. You can see there was only one pole which shows three different colors like green, amber or red. So pole is an example for variable, and green, amber and red colors are the examples of for values which we store inside that memory box. So when the color of that any traffic signal may change depending upon the situation. So sometimes it may be green, it may amber, it may red. Depending upon the requirement, the value of the variable may change in programming. So this is the simple concept we should understand. So here in this topic we understand three things. What is variable? What is state? Variable is nothing but a name of the memory location. In memory location we try to store the values, that is called data. The data may be input data, it may be output data. The data at the time of executing the program, it may change. That change value is known as state. So this is the three concepts we understand in this topic. Now we are going for the third block of algorithm called control flow. So in programming, sometimes we want to repeat the same instruction or same steps again and again and again and again for achieving the result. In same way, sometimes we want to skip some of the instruction, and some of the instruction should be executed. So depending upon the requirement, we may skip or we may repeat the group of statement. So this is called the control flow. An algorithm is a sequence of statement. However, after executing a statement, the next statement to be executed need not be the next statement in the algorithm. The statement to be executed next may depends on the state of the process. There are three type of control flow in algorithm. Number one, sequential control flow. It means there was no repetition, there was no skipping in instruction. In a program or in an algorithm, a sequence of statements are executed one after another in the same order as they are written. So here in sequential control flow, there was no skipping of statement, there was no repetition of statement. In the second control flow, you can see an alternative control flow. A condition of the state is tested, and if the condition is true, one statement is executed. If the condition is false, an alternative statement is executed. Here in alternative control flow, skipping was executed or skipping was implemented. Some statements are skipped, some statements are executed. So depending upon some condition, we skip some statement, we execute the alternative statement. This is called the alternative control flow. The third control flow is iterative control flow. So in this statement, we try to repeat the group of statement or a single statement till some condition becomes false. So these are the three types of a control flow. One, sequential flow, where all the instruction, all the steps in algorithm are executed from first step to last step. In alternative control statement, whenever the statement executed, depending upon some condition, a group or a single statement may be skipped and the alternative statement may execute. It is depend upon the condition. So this type of sequence is called alternative control flow. Third one is iterative control flow, where a group or a single statement may execute more than one times. More than one times. So these are the three type of control flow: sequential control flow, alternative control flow, iterative control flow. So now we are going to see the third block of algorithm called function. So this is a very important topic or important concept in algorithm. Algorithms can become very complex. It is up to the problem. The variables of an algorithm and dependencies upon the variables may be too many, then it is difficult to build algorithm correctly. In such situation, we break an algorithm into parts. Construct each part separately and then integrate the parts of the complete algorithm. That part of an algorithm are known as functions. So function is the part of an algorithm. A function is like a sub-algorithm. It means a algorithm which was very complex is divided into small algorithms, and small algorithms are separately designed. After designing the small algorithms are combined into a big algorithm. So this is called sub-algorithms. So this is called function. So a function is just like a sub-algorithm which accepts its own input, it produces its own output, it have its own procedure to solve the problem. So each and every function produces a small result, and these small results are collected and constructed into a single unit, and this single unit becomes a big algorithm, and this big algorithm gives a big solution to big problem. In example, you can see, suppose you want to calculate the surface of area of cylinder of radius r and height. So what will be the formula? Here you can see a is equal to 2 pi r square and 2 pi r h. We can identify two functions, one for calculating the area of circle and the other for circumference of the circle. So if we abstract the two functions as circle area and circle circumference, then cylinder area can be solved. So if you want to find the cylinder area, we can simply add the results of two functions. One is the circle area, another one is circle circumference. So 2 pi r square produce the area of the circle, 2 pi r h produce the circumference of the circle. By using these two value we can produce the third value called circle area. So we divide this function finding the area for cylinder into two small algorithms. One is for finding the area for circle and finding the circumference for the circle. So here you can see two small functions, two small parts produce two small result. When these two results are connected and added, we get the result for cylinder area. So this is the simple example for understanding the function. So functions are the sub-algorithms. In programming, we can call sub-programs or subroutines. So this is the fourth building block of algorithm. I hope you understand what is the concept discussed in this chapter. So try to go through the chapter again and again. Read the every line, each and every line. So repeat the reading process. So this was a concept based chapter. So we should know what is the concept. So here the main concept is we should know what is algorithm. We should know how we can calculate or produce an algorithms. So for algorithm creating what we need the four building blocks called data, variables, control flow and functions. So we will see in the next class the continuity of the same class. Assalamu alaikum.